All right, greetings everyone. Welcome to the first part of this video for section 5.5. And in section 5.5, we'll be getting into some applications of trig or some uses of trig that are probably more familiar to you because we'll be talking about right triangle trigonometry. So if you've seen trigonometry prior to this class, it's probably been in the context of right triangles. Okay, so in this sense, or in this section, we're going to define our trig ratios, sine, cosine, and tangent, in a little bit different way. So you'll see here in our picture we have a right triangle. We've identified an angle theta here. And then we have identified the sides of the triangle in relation to that angle theta. So the first one that might be the easiest to identify or understand is the one that's opposite, which is very simply the side that is across from the angle we're dealing with. The next one that you might be familiar with is what is called the hypotenuse, which is always the side, the longest side of a right triangle. And it will also always be the side opposite the right angle in a right triangle. Okay, so that's our hypotenuse. And then that leaves the last side here, which we will refer to as the adjacent side. And adjacent is a word that just means next to. And so notice that the adjacent side there is next to, it actually touches the angle that we're dealing with. And you might also think, well, the hypotenuse is also adjacent, right? It is also next to it. But again, remember the hypotenuse is special and it's the longest side across from that right angle. So that's why it's not called the adjacent side. So the adjacent side is always the side next to the angle that is not the hypotenuse. Okay, with those definitions in place, then we can define our sine, cosine, and tangents. The sine then of the angle we'll define as the length of the opposite side over the length of the hypotenuse. Cosine we'll define as the length of the adjacent side over the length of the hypotenuse. And then tangent of theta as the length of the opposite side over the length of the adjacent. And one way to remember this that you may have heard before, a common phrase folks will use is SOHCAHTOA. Okay, and where that comes from here is when we're talking about sine, well, it's opposite over hypotenuse, so that's why we have the O and the H, so. Cosine is adjacent over hypotenuse, so we have cosine is A over H. And then tangent is opposite over adjacent, so we have T is O over A. There, so SOHCAHTOA is one way to remember the relationships here. Now I'll also point out that we can use these to also define our other trig ratios in terms of these sides. So we could talk about cosecant of the angle, secant of the angle, and cotangent. And recall that each of these is the reciprocal of their related standard function. So for cosecant, we could say that it is hypotenuse over opposite. So I'm just going to use H and O there. So again, the reciprocal of what sine is. Cosine, or excuse me, secant then would be the reciprocal of cosine. So it would be H over A, hypotenuse over adjacent. And then cotangent, again, would be the reciprocal of tangent. So it would be A over O, or adjacent over opposite. So we can do those ways. All right. Great. So let's apply these now to do some work with right triangles. I'm going to do what I call solving right triangles. And this is just a fancy way of saying finding all of the missing information. So I'm going to add some information to this triangle. So I'm going to tell us that this lower angle here has a measure, whoops, not that, sorry. This lower angle here has a measure of 65 degrees. And then the side right here next to it has a length of 5 feet. And so what we need to do is find all of the missing information here. So the length of all missing sides and the measure of any missing angles. So, and I'm going to actually go ahead and label those. So I'm going to call this missing angle here beta. I'm going to call this missing side over here, I'm going to call it lowercase b. And then this side here I'm going to call c. So we need to find the measure of beta, lowercase b, and lowercase c. Let's start with beta. So that's the measure of this missing angle here. And there's a couple of different ways we can go about that. One of the ways is that we know that the sum of all three angles in a right triangle is 180 degrees. So therefore, we should have that beta, the angle we don't know, plus the 65-degree angle, plus, well, this other angle right here. That's what tells us this is a right triangle, so we know the measure of that. So the measure of that angle there would be 90 degrees. And we know again that the sum of all three of these angles should be 180 degrees. And so now we can just simply solve for beta. So I can do beta plus add the 65 and the 90 would give us 155 degrees equals 180 degrees. And then we subtract 155 from both sides. And when we do that, looks like we find that the measure of angle beta then, 180 minus 155, I think is 25 degrees. Yeah, 25 degrees. So the measure of beta here is 25 degrees. Okay. All right, so now we've got that information. Let's work on finding the length of side lowercase b and side lowercase c. And I'm going to start with side lowercase b. And we'll want to make use of those trig ratios we were just talking about somehow. And to do that, let's look at again at the information we were given. So we're given this angle here. We're also given this side here next to it, and we're trying to find this side here. And let's also think about how those sides relate to that angle in terms of opposite, adjacent, and hypotenuse. Well, first of all, it looks like the side B, that's across from that 65-degree angle, so that's going to be the opposite. And then that side of length 5 feet, well, notice it touches the given angle, so it's right next to it. It's also not right across from the right angle, so it's not the hypotenuse. So that tells us this one here must be the adjacent side. So it looks like we're dealing with the opposite side and the adjacent side here, which if we again recall from the previous slide what that means, it's going to tell us we're dealing with tangent, because we know the tangent of an angle is equal to the ratio of the opposite side over the adjacent. And we can now plug in the information we have. So we know the measure of the angle here is 65 degrees. The opposite side, that's that length b that we don't know. The adjacent side has a length of 5, which we do know. And now we can just simply solve for b, so we'll multiply by 5 on both sides. These will cancel. So then we have that b is equal to 5 times the tangent of 65 degrees. And then now to find the value for b, or the approximate value for that, we can go ahead and plug 5 times tan 65 into our calculators. Now make sure when you do this, your calculator is set to degrees mode. And if you're not sure if it is or how to do that, please let me know. I can help you do that. But in this case, making sure mine's in the correct mode, and I do in the calculations, I find that the length of side B is 10.722, and I want to use my given units here, which is feet. Okay, so I know that this is 10.722 feet now is the length of side B. Okay, now we need to find the length of side C. And to do that, now that we know the lengths of the other two sides of the right triangle, We could use the Pythagorean theorem to find that, especially because it's the length of the hypotenuse. But we want to be careful when we're doing problems like this of using values that we've had to come up with, especially if we had to round them. So for example, if I was going to use the Pythagorean theorem to find the length of side C here, well, I'd set it up as C squared equals 5 squared plus 10.722 squared. And again, notice that this 10.722, that's a number we had to round to get. And so it'll throw off our accuracy with finding C. So we instead want to stick here with just using the information we were given, which in this case was once again the 65-degree angle in this length of side length of 5 feet. So we're going to again think about the sides we're dealing with and how they relate to the angle. So the 5-foot angle or 5-foot side is still going to be the adjacent one there because it's right next to the angle. The side of length C here, we'll notice, as I pointed out, it's opposite the right angle. So that tells us we're dealing with the hypotenuse here. And so then we have to think about what is the trig ratio that involves adjacent and hypotenuse. Well, the answer there is cosine. So we know we're dealing with the cosine of an angle is equal to the length of the adjacent side over the length of the hypotenuse. Well, again, plug in the information we're given. So cosine of 65 degrees equals the length of the adjacent side here, which is 5, over the length of the hypotenuse, which we're calling C. And now we need to solve for C. Well, notice this is a little bit different than the last one because in this case, the variable we're trying to find is here in the denominator. However, we are confident, strong mathematicians, we can deal with this. To do that, the first thing we're going to do is actually get that C out of the denominator. So we can do that by multiplying by C on both sides. When we do that, these cancel. So we have 5 equals C times cosine of 65 degrees. And then we can isolate the value for C there by dividing by cosine of 65 degrees on both sides. And so these cancel. And so we have then that C equals 5 over the cosine of 65 degrees. We can go ahead and plug that into our calculator. And I get that the length of the hypotenuse here would be 11.831 feet. So that would be our value for C here, 11.831. Put the feet on there. Okay, and so now we've solved this right triangle. Again, we found the lengths of all missing sides and the measures of all missing angles. All right, that's it for now. Thank you for watching.